Good morning, viewers. This is Kasturi Day. Today, I'm going to again start the discussion with this element, compound, and mixtures chapter according to ICSE syllabus, class 8. So, continue with that. For class, the question number 8, I'm continuing to starting with today. So, it is classify the following substances into compounds and mixtures. Now, carbon dioxide, first one is carbon dioxide. It is a compound because carbon and oxygen chemically combine together to form a compound. Then air. Air is a mixture because the constituent elements of the air, they are not chemically combined. Then water. Water is a chemical, it is the constituent elements, that is hydrogen and oxygen, they are combined together to form this water, and that's a chemically that's a compound. Then milk, the constituent elements of milk, they are not chemically combined, that's why it's a mixture. Then common salt, that is formation of sodium chloride. Sodium chloride, common salt, chemically it is sodium and chlorine mixed together, chemically combined together to form compound. Then blood. Blood is also a mixture because it is the constituent elements of blood, they are not chemically combined. Then fruit juice, again the constituent elements of the fruit juice, that is they are not chemically combined. Okay, that's why it's a mixture. Then iron sulfide, it's a compound because iron and sulfur, they are chemically combined to form a new pure substance, that's a compound. Then give one example for each of the following types of mixture: the solid homogeneous mixture, solid liquid homogeneous mixture, miscible liquids, and liquid gas homogeneous mixture. So first we are coming to solid homogeneous mixture. They are alloys, example is brass. Then solid liquid homogeneous mixture, clay and water. Then miscible liquid, solid is clay, clay is solid and liquid is water. Then miscible liquids, ethyl alcohol. Okay, ethyl alcohol mixed with water, that is mixed together. Alcohol mixes with water. So then a liquid gas, homogeneous mixture, water and carbon dioxide. That's a homogeneous mixture. Then suggest a suitable technique to separate the constituents of the following mixtures. Also give the reason for selecting the particular method. First is salt from the seawater. Okay, so how do we separate salt from seawater? See, we can evaporate the seawater, evaporate the water from the sea. The seawater we can evaporate, and we will get the residue as the salt. Okay, because common salt is not volatile, it is non-volatile, while water can evaporate. Okay, that's why we can use this process of evaporation to separate common salt from the seawater. Then ammonium chloride from sand. Now ammonium chloride is a volatile substance, it can sublime. Okay, excuse me, but sand is not. So we can separate it by sublimation method, where ammonium chloride will sublime, and we can collect it on by cooling it down. Okay, and while it is subliming, the sand will be left behind, and we can separate the sand from ammonium chloride. Then chalk powder from water. Now chalk powder, this can be separated because separated by simple method as is filtration, because chalk does not dissolve in water. Okay. Now if we pass it through filter paper, or by filtration method, if we pass it through the filter paper, then we can get the residue as the chalk, and the water will be collected as filtrate. Now iron from sulfur. Now iron and sulfur, they can be separated by magnetic separation, because iron is a magnetic substance. Okay, but iron can be attracted by magnet, but sulfur is not. So we can separate it by magnetic separation. Then The water and alcohol. Now see, water and alcohol, these this mixture is a homogeneous mixture, miscible liquids these are. So we can separate this by only fractional distillation, where they will differ in their boiling point. Water will have a separate boiling point and alcohol will have a separate boiling point, and we can collect it accordingly. First we'll get back the alcohol, because alcohol boils at much lower temperature than water. So first we'll collect the alcohol, then we'll collect the water. Then sodium chloride and potassium nitrate. Okay. Now, sodium chloride and potassium nitrate can be separated by fractional crystallization, as potassium nitrate is more soluble in water than sodium chloride. Okay, both of them will dissolve in water. Then we'll go on dissolving in water, both of them, sodium chloride and potassium nitrate. And we will see that the potassium nitrate is dissolving more in water than sodium chloride. And then we will heat the temperature, and we'll see that more of potassium nitrate is being dissolved, and when we cool down, we'll cool down the mixture, we will see that potassium nitrate is coming out first. So fractional crystallization, we can separate the potassium nitrate from sodium chloride. Another is calcium carbonate and sodium chloride mixture. Now, this can be separated by solvent extraction method, as calcium carbonate is insoluble in water and sodium chloride will dissolve in water. Okay. Now, sodium chloride can be separated by this. First, we will dissolve in water, then calcium carbonate will not dissolve, sodium chloride will dissolve. Now, by filtration, we will separate the calcium carbonate. Okay. Now, the sodium chloride, which has dissolved in water, we can evaporate the water, and the residue which we will get is the sodium chloride, because sodium chloride is not volatile. Okay. Now, the next question is define mixture and why is it necessary to separate the constituents of a mixture, and state 4 differences between compounds and mixture. First, what is mixture? Mixture is a kind of matter which is formed by mixing 2 or more pure substances. It may be elements, maybe compounds, or both, in any proportion such that they do not undergo any chemical change, and also they retain their individual properties. There's no chemical change taking place between them, and they can retain their individual properties. Okay. Next is why do we need to separate the constituents of the mixture? Because we need many substances to make our life convenient and comfortable, but most of the substances which are available in the nature, they are in the form of mixtures. Okay, so these mixtures contain many unwanted substances which may be harmful for us, or may degrade the properties of the mixture. That's why it's necessary to separate the components of the mixture. Now, the difference between a compound and a mixture. A compound is a pure substance, whereas a mixture is an impure substance. A compound always is homogeneous, whereas mixture may be homogeneous or heterogeneous. Now, compound has a fixed composition, whereas mixture, they have no fixed composition. Then compound components can be separated only by complex chemical means, chemical processes, whereas mixtures can be separated by simple physical methods of separation. Okay. Next, we come to what is chromatography and for which type of mixture it is used. What are the advantages of chromatography, and give 2 applications of chromatography. The first is, what is chromatography? Chromatography is a process of separating different dissolved constituents of a mixture by their adsorption on an appropriate material. So this is a process of separating the constituents of a mixture. Okay. Different dissolved constituents, both of them, what are the constituents of mixture? All are dissolved condition, in the dissolved condition. Okay. And they can be separated on the principle of their adsorption. Adsorption properties is used here on a appropriate material. Okay. Now this technique is used, and for which type of mixture it is used? This technique is used to separate the components of homogeneous mixture based on the solubility of the homogeneous mixture. Based on the solubility difference of the components in a solvent or solvent mixture. Okay, in which the dissolved substances are colored. Okay, the dissolved substances are colored, and they're based on the solubility difference, they can be separated out. Now, advantages of this is very small quantity of a substance can be separated here. Okay, the components with very similar physical and chemical properties can be separated. Okay, it identifies the different constituents of the mixture. It also helps in quantitative estimation of the components of the mixture. Okay. So for this method for separation, a very small quantity is sufficient for that. And very similar physical and chemical properties of the components can also be separated. The components which are having very similar physical and chemical properties, that type of components can also be separated by this method. Okay, then it identifies the different constituents of the mixture. What are the constituents of the mixture that can be identified by this method? Even the quantitative estimation of the components can also be identified from this method. Okay. Then the application, it is used to separate the colors in a dye, drugs from the blood, then pigments from natural natural dyes, you can say. From the natural dyes you can separate the pigments. Then to purify many industrial products also, this can be used. Okay, next is describe the method of separation of the constituents of calcium carbonate and sodium chloride, and describe the method of separation of the constituents of kerosene oil and water. So for calcium chloride and sodium chloride, calcium carbonate and sodium chloride mixture, I told you they have to be first dissolved in water, and then they can be separated. This calcium chloride will not dissolve in water, whereas sodium chloride will dissolve in water. Okay, and we can separate them by filtration method. Calcium carbonate can be found as, can be separated as other residue, and sodium chloride solution will be the filtrate. Now the calcium carbonate, the residue of, the water which is left in the calcium carbonate can be dried up. Okay, and then the sodium chloride, soluble sodium chloride, which has been obtained as a filtrate, that can be evaporated. Water will get evaporated, leaving behind the sodium chloride, common salt. Okay, then for separating the kerosene and oil and water, we need a separating funnel. Then separating funnel, it's a long glass tube with a tap. The mixture is poured into the funnel and it is allowed to stand for half an hour or more. We will see that this liquid will separate according to their difference in their densities. Kerosene being lighter will be above, and water being heavier, it will be in the below this kerosene oil. The funnel is placed in the vertical position in an iron stand. The tap of the funnel is closed. The heavier and denser liquid of water forms the lower layer, and the lighter and the less denser liquid, that will be kerosene, that will be the upper layer. Then conical flask is placed with the just below the nozzle. Then first we take out the water. As it is heavier, it will come out, and then we'll collect the kerosene oil in another beaker. Okay, like this. This is the process. See, separating funnel is attached. This conical flask, kerosene oil is above, water will be down. Okay, so I think I'll stop here. I'll continue with the rest of the quiz discussions in my next video. Please go through this. If you have any doubt, please do write in the comment box. And I'll suggest to go to the text videos first, and then you refer to these question answer videos. Okay, and that will help you in your studies. And still, if you are having any problems, please do write in the comment box. Do share with your friends and colleagues so that they can also be benefited from these videos. And do subscribe to get the notification of my next video. Thank you. Thank you for watching and have a good day.